Live. All right. Good afternoon, superstars. I'm so excited to have us here again. Um, so it's time for math class right now, and I'm going to be doing a brief recap of what we talked about yesterday, what we learned yesterday. Pretty sure quite a number of us were here yesterday, and if we were not here, I'll do a brief recap of what we did yesterday. All right. So yesterday we talked about something very interesting. The first time I met with us, we talked about the laws. There are some interesting laws of indices, right? And we talked about the multiplication law. We talked about the division law. We talked about the fractional index law. All right. So yesterday we talked about arithmetic progression. We talked about AP. We solved some questions regarding AP and the likes. So today, what we are doing is simple. And the reason why I said it's simple is because this particular topic in mathematics, a lot of people are scared of it. They feel, oh, really, can I even solve questions when it comes to this particular topic in mathematics? So I want to assure you that this afternoon we'll be breaking down some concepts as relating to probability. All right. So what we are doing today is probability. We'll be looking at some concepts, some questions regarding probability. All right. So let's move on. So the first thing we're looking at is the definition. What is probability itself, right? So if I say a probability of an event occurring, what do I mean by that? What I'm saying in essence is that the chance of a specific event will occur. That's the meaning of probability. So if I say I'm going somewhere tomorrow, Saturday, what is the probability that I'm going to be there tomorrow? What I'm saying in essence is what is the chance that will be in this particular place tomorrow? That's what probability is all about. All right. So in probability, we have some terms I'll be just defining for us. I will be explaining them also. The first one I'll be explaining is the sample space. All right. So, for instance, if you have a die, I'm pretty sure some of us here will play Ludo, right? So there's this small die that you just roll and just play. If you have a die, for instance, die has six sides to it: one, two, three, four, five, six. Those are the six sides of a die. So if I throw a die up, the sample space is what I mean by the possible outcomes I will get from that die. All right, all possible outcomes I will get from that particular die. So if I throw a die up now, let's say I just throw it up, I can either get one, two, three, four, or five, because those are the numbers on that die. All right, so what we are talking about, sample space, we are just talking about all possible outcomes of an experiment. If I perform an experiment, what are the possible outcomes of this particular experiment? So in throwing of a die, I'm either expecting, one, two, three, four, five, or six. So I can either expect any of them to happen, to show when I throw my die up. So that's what we mean by sample space. It's just all possible outcomes of an experiment. All right. So now, what is an event? An event is simply, the possible outcome of a combination of outcomes. Possible outcome or a combination of outcomes. So it could be that, for instance, if I have a coin, if you throw a coin up, if you toss a coin, that's what it means. If you toss a coin, you can either get a head or a tail. All right. So if I say what is the probability of getting either head or a tail, what I'm asking is that what is the possible outcome of either getting this particular head or tail? Okay. So sample space is just all possible outcomes of an experiment. Why an event in itself is a possible outcome or combination of all the outcomes that can be from that particular event. So let me go over it again. Probability is just saying the chance of a specific event occurring. That's its probability. The chance of a specific event occurring. That's its probability. So sample space in itself is all possible outcomes of an event. So if you understand what probability is, which is the chance of an event occurring, then sample space is all possible outcomes. Like I said, if you toss a die or a coin rather, the probably all sample space of tossing a die or a coin in this case is either head or tail. All right. But for a die, the sample space is what? 1, 2, 3, 4, 5, and 6. So all possible outcomes. That's what we mean by sample space. But an event is that when you toss a die up, right? What is the probability of getting head or getting 1 or getting 2 or getting odd number or getting, even number? So that event is, particular to that what you are looking for. So if I say what is the probability of getting even number when you throw up a die? So I'm talking about events, but sample space talks about everything, all possible outcomes of that particular, experiment you are carrying out. All right. So another one is equally likely outcomes. Equally likely outcomes. So when the chance of any outcome occurring is equal to the probability of the other one occurring, that is what we mean by equally likely outcomes. So I'll give an instance. So if you toss a coin, the probability of getting a head is what? 1/2. I'll still tell you the reason why it is 1/2. The reason why it is 1/2 is simple. When you toss a coin, you can either get the head or the tail. Coin has two, so what's it called now? Two faces, right? Two sides. When you toss a coin up, you can either get head or tail. You can't get the two at the same time. Okay, so equally likely outcomes in this case means the probability of getting head is 1/2. Probability of getting tail is 1/2. So meaning they are equal, isn't it? So if I toss a coin once, probability of getting either tail or head is equal because both of them will give me what? 1/2. Why is it 1/2? Because we said something that sample space is what? All possible outcomes of an experiment. So what are the all possible outcome of me tossing a coin? It's 2. Head, tail. Head, tail. Now, what we are dealing with is the number of outcomes. So in this case, now I'm not dealing with tail alone. I'm not dealing with head alone. I'm dealing with the total number of possible outcomes. So when I toss a die up, I can either get head or tail, which is 2. So that's the total number of what? Outcomes. So if the question now says, what is the probability of getting head when you toss a coin once? It will now be what? How many head can I see there? 1. It will now be 1/2. 1/2. All right? 1/2. So that's the probability of getting what? Head or tail. 1/2. All right, so let's move on because I really want us to solve a lot of questions today. All right, so another thing we'll be talking about, the fundamental properties of probability we'll be talking about is range. So when I say range, I'm saying the value of probability always lies between 0 and 1. 0 and 1. If your answer, whenever you're doing probability, anything related to probability, and you're getting your answer to be 1.2, just know right away that you are wrong. Probability cannot be more than 1 and cannot be less than 0. All right? The value of your probability will always give you any value between 0 and 1. Why is it so? Because now it is so because any possible outcome, if you want to calculate the probability of any outcome now, for instance, let's still use die, for instance. What's the probability of obtaining even number when you throw a die up once? All the total possible outcomes of throwing die once is what? 6. That is 1, 2, 3, 4, 5, and 6. So you can either get 1 or 2 or 3 or 5 or what? Or 6. That makes it what? Total possible outcomes is what? 6. Now, the question now says, what is the probability of obtaining even number when you toss or when you throw the die up? What are the even numbers there? Even numbers in 1, 2, 3, 4, 5, 6 are what? 2, 4, and what? And 6. So that makes it how many? 3. 3 even numbers. So the probability of obtaining even number when you what? Throw a die up will give you what? 3/6. And that is probability. And that 3 over 6 will give you what? 1 over 2, which is 0.5. Can you now see that it lies between 0 and 6? 0 and 6. So you can't get your answer for probability question cannot be more than 1 and cannot be less than 0. Because you can't get in an event, you can't get a possible outcome that is greater than the summation of all the possible outcomes that are there. It's like saying you want to throw a die up and you are getting even number. We've gotten the number of even numbers there now, 2, 4, and 6, which is 3. Even numbers there now cannot be 9, for instance, because the numbers we are dealing with is 1, 2, 3, 4, 5, and 6. So the possible outcomes are what? 6. So the even numbers there are what? 2, 4, and 6. So that makes it what? Total number of 3 for even numbers. So if you say the probability of getting even number when you throw a die up, it will give you 3 over 6. It can't give you 9 over 6 because the number of even numbers there is not even up to 4. The maximum there is what? 3. And that's why I said it can't be more than 1 because you can't get any from your event. You can't get anything more than all the possible outcomes of that particular experiment. So I hope you are following this. If you are following, please drop it in the comment section that you are following because it's very important you understand these basics before we start solving questions. All right. So another one is certainty and impossibility. So when I say something is certain, the probability of this thing happening is certain. That means the probability will be 1. So for instance, if I say I'm going somewhere tomorrow and the probability I'm going to go there is 1, that means I'm saying it is certain I'm going there. So there's no impossibility I'm not going there again tomorrow. So certainty in probability means probability of an event occurring is what? Is 1 because it is certain it's going to happen. Probability that 6 p.m. will get to 6 p.m. today, or that 6 p.m. would, meet you in the office. You might, of course, for some of you, probably are in your school right now, you know the time you close, right? From school. Let's say you close by 5, or maybe let's say you close by 4. So someone can ask you, what's the probability of you staying till 6? You know that one is not certain because you know that school closes by 4. So the probability of you staying till 6 is not certain. So you can't say that is a certainty. But if someone should ask you, what is the probability of you staying in school till 3? You know that it's certain you must be in school till 4. I don't know whether you understand what I'm saying now. So let me go over this again. Certainty in probability means the probability of an event occurring is what? Is 1. It is certain. So if your school closes by 4, for instance, if you're in school right now, and your school closes by 4, and you know that you can't leave school until that 4 p.m. And someone asks you that what is the probability of you staying in school till 3 p.m.? Is it certain or impossible or not certain? It is certain because you know that you can't even leave the school premises until 4 p.m. So the probability of that event occurring is 1, meaning that it is certain I will be in school till 3 p.m. But if someone should ask, what's the probability of you staying in school till 6 p.m.? You know that school closes 4 p.m., right? Even though you play with your friends after school, you know that give or take 1 hour, you're done. And you're not sure whether you still be in school till what? Till 6. That means it is uncertain. So you can say the probability of that happening maybe is 1 over 2. Half. I can be in school or I might not be in school. But the probability of you being in school till 3 p.m. is certain. It is 1. So that's what we mean by certainty in probability. And the impossibility in probability means it is not possible. This event will never occur. This event will never occur. So the probability of this event occurring is 0 in probability. That's what we mean by impossibility. So certainty means it is possible. It is very, very possible. And that is what is happening. There's no change to it. Probability of you writing JAMB. All things being equal, God willing, Jesus tarries in his coming. Of course, all of you want to write JAMB, isn't it? Probability of you writing JAMB is certain that you're going to get to that stage where you write your own JAMB, right, and enter the university. That's certainty. But if I say, what is the probability of you entering into the university? For some, they just want to, write JAMB and just test their knowledge. For some, they might not even be in school already. and they just want to just write jam again to just test their knowledge, probability of them entering the university for them is impossible because they are already in the university. So I'm saying all of this to bring it to the point where you can understand what probability is, right? I'm using this practical example so that you can understand what probability is. So certainty means the probability of an event occurring is 1. Impossibility means the probability of an event occurring is what? Is 0. So let's move on. Mutually exclusive events. When we say something is mutually exclusive, what are we saying? Two events are mutually exclusive if they cannot occur at the same time. I will still use a practical example for this. Two events are mutually what? Exclusive if they cannot what? Occur at the same time. So for instance, what is the probability of, let me just check from the chart. Let me just check from the charts now. Okay, I can see Azan here, I can see Uchechukwu here, I can see Eniola here, I can see Folake here now. So let's say, what is the probability that Folake will be in Oshodi by 2 p.m. and also be at Yaba by 2 p.m.? You know that it is impossible. You can't split yourself into two, isn't it? So you can't be in a place and be in another place at the same time. So that means the two events occurring together, they are mutually exclusive. They can't occur together. You can't be here and be there at the same time. That's what we mean by mutually exclusive events. So two events are mutually exclusive if they cannot occur at the same time. You can't be in church on a Sunday, that same time, 9 a.m. you are in church, and you are still in a mosque somewhere else, 9 a.m. It's mutually exclusive. Those events are mutually exclusive. So when we say two events are mutually exclusive in probability, we are saying they cannot occur together. They cannot occur together. All right? So the opposite of that is what? Independent events. So it is English. So even by the time you're writing your jam, if the question says, oh, two mutually exclusive, blah, blah, just remember independent, that this is the opposite of mutually exclusive events. And independent means what? One is not affecting the other. So in probability, independent event means two events are independent if the chance of one occurring is not affected by the occurrence of the other. By the occurrence of the other. All right? So let me give another practical example here. All right? So let's assume that I have a match I'm going to play tomorrow. All right? By 9 a.m. I have a football match I'm going to play with my friend by 9 a.m. And I have another party. And that football match is roughly 45 minutes, I'll be done. And I have a party, maybe a birthday party with someone. And the birthday party is like 4 p.m. tomorrow. Now, you know that those two events are what? Are independent of the other, because I can be at that football match by 9 a.m. and still make it to what? To the birthday party by 2 p.m. or 4 p.m. So those two events are independent of the other. But mutually exclusive events is saying that these two events, they can't occur at the same time. So you can't be here and be there at the same time. That's what we mean by mutually exclusive events. I just hope you are following this as I'm saying it, because it's very, very important. It's very, very important. Let me also drive this home by saying, if I toss a coin once, the probability of obtaining head and obtaining tail are what? Mutually exclusive. So I can't obtain the two together. So they are not independent. They are mutually exclusive events. If I toss a coin up, I can't get both head and tail at the same time. It's not possible. It is not. You can either get head or get the other face, which is what? The tail. So that's a mutually exclusive event. But if I toss it, or I have two coins, for instance, and I toss it once, you know that the probability of obtaining both head is very possible. I can obtain head here and obtain head in the second coin. That's what we call independent what? Events. But mutually exclusive events is saying two events are mutually exclusive if they cannot occur at the same time. So please have this at the back of your mind. Two events are what? Mutually exclusive if they cannot occur at the same time. All right. So another example, or let's move on because of our time. Laws of probability. So there are some laws we have in probability. Like I told you in our first class, on Wednesday, that mathematics, principles are guided by laws. Mathematics basically is guided by laws. Principles. There are principles that guide mathematics. All right. So there are laws, like you have the law of indices, we have laws of probabilities. So if you understand these laws, you'll be able to answer your questions. All right. And the goal here is simple, to make sure everyone here get the desired score. Okay. To make sure everyone gets the what? Desired scores. All right. So, okay, someone said, yeah, he said Folake has powers to be there and to be here at the same time. Okay. You know that. I don't know that. All right. So laws of probability. The first law we'll be mentioning is the addition law of probability. Addition law of probability is simple. All right. If I say the addition law of probability, what I'm saying is for mutually exclusive events, don't forget what we said about mutually exclusive events. They kind of occur together. The probability of either occurring or one occurring is what we call P A union B. So A union B in probability is saying probability that A or B will occur. A union B, you see these notations, right, in sets, often in sets, but they occur also in probability, right? A union B, P, let me make this to be bolder. All right. So if I have P, that is probability is represented by P, all right, don't forget. P equals to A union what? B. What I'm saying is that probability that A or B will occur, that's what it means, A union B. A intersection B is saying probability that A and B will occur together. Intersection, union, intersection, like you have it in sets theory. Intersection, union. So union here in probability is saying that probability that A or B will occur. But intersection is saying that probability that A and, see what I used there, and not occur, A and B will occur together. Like we have in set theory too that say all the elements of that set. So we are not dealing with sets now. This is probability. So I'm just bringing it down to probability. So A union B in probability is saying probability that A or B or both will occur. It is all. And all in probability is the addition plus. Always remember this. In probability, any question you see and you see probability that this event will occur or this event will occur, meaning you had the two events together, and this is it. P union B equals to what? P of A plus P of B, meaning probability that A or B will occur will give us probability that A will occur plus probability that B will occur. Please, are you getting it? And that's why I am saying, someone is saying there's a lag. Please, can you confirm if there's a lag? The network is good here. Please, can someone confirm if there's a lag so that I can know? All right, so let's move ahead. Multiplication law. All right, the multiplication law says for independent events, the probability of both occurring together is P intersection B equals to what? P of A times P of B. I will explain that. For independent events means two events are independent if they are not dependent on each other. One occurring doesn't affect the other one from occurring. That's what we mean by independent events. So multiplication laws deals with that because you are dealing with independent event. That means this one occurring is not affected by the other one occurring. So the formula here is simple. You use multiplication. In addition law, we use what? Plus. In multiplication law, we use what? Times. So probability that Both events occurring together will give you what? P, probability of A times probability of B. Let's move very fast. Sampling, all right? So that deals with when we are selecting item, putting it back into container. You see questions like that in your JAMB a lot. What's the probability of obtaining a red ball? From if I have a box that contains 2 red balls, 3 yellow balls, and 4 blue balls, what's the probability of obtaining a red ball? That's what we call sampling, all right, in probability. So sampling can either be with replacements or without replacements. With replacement or without replacement. Please note that. With replacement or without replacement. All right. So there's a question here that I have here, but it's not in this slide. It's a brain teaser question, right? So I'll just give you. Let's solve this before we move on. So let me just give that brain teaser question. So you can note it down. If the letters of the word probability. Now note this question. If the letters of the word, now we've started solving questions now. If the letters of the word probability are cut and dropped into a bag, and the letter is selected at random from the bag, find the probability that the selected letter is a vowel, B, an I, C, a P. I'll come again with that question. It says, if in a class, okay, this question says, if the letters of the word probability, let me write it down. Letters in the word probability. Probability. So if the letters in the word probability are cut and dropped, that is, you cut the letter, you cut P, R, O, B, A, B, I, L, I, T, Y. All right. If you cut them, how many letters are there? Let's count them. Probability 1, 2, P, R, okay, 3, 4, 5, 6, 7, 8, 9, 10, and what? 11. So probability has how many letters now? 11 letters. So the question is saying, if you cut the word probability, if you cut each letter and you drop it in a bag, that's what he's asking. Now, the question now says, find the probability that the selected letter is what? Is a vowel. Now, what is the total outcome? What is the total what? Outcome? That is what should be after. What is the total outcome of this particular event? The total outcome means here, the total number of letters we have. That is it. Don't forget, probability of an event occurring. Let's go back to our formula here. It says what? PE equals to M over N, where M is the total number of outcomes and N is what? Is the outcome, likely outcome of that event. The total number of outcome, number of required outcome over total number of what? Possible outcome. Let me write it down here so that we can understand better. So let me just write it. P, probability of an event occurring. Just note this, please. Let me write it somewhere here. Good. Probability of an event, P of E equals to what? Number of, you understand this better, number of required what? Outcomes divided by total number what? Of outcomes. Total numbers of possible outcomes. Possible outcomes. All right. Total number of possible outcomes. All right. So someone dropped an answer already. Let's see whether it's correct. So probability of an event occurring is what? Number of required outcomes over total number of what? Possible outcomes. Now, what are the total number of possible outcomes in probability? The word probability will give you how many letters? Total number of possible outcomes is what? 11. 11. All right? 11. 11, that's the total number of possible outcomes in probability, because it will give you how many, what's it called now? How many letters are there in probability? Don't forget, the question is saying you have cut each letter. So the total number of outcomes, that means in the box now, how many letters are there? 11 letters. So the question now says, what is the probability of obtaining a vowel? Vowel. Now, in mathematics, it's very important you understand English also, right? If you don't understand English, it might be impossible for you to solve mathematics questions, especially when it comes to word problem questions, all right? Vowel. We have A, we have O, we have I, we have O, U, and all of that. So how many vowel letters can you see in the word probability? Probability. We have O, that's one. That's one vowel letter. We have what? A. We have another one, which is I. Don't forget, we have another what? I. We have another I. Please don't forget. Don't think because I occurs twice, you now take it as one. Don't forget that we've cut the letters into what? Each letter, we've cut them and we have put it in the box. So 11 total possible outcomes are there. How many vowels are there? We have what? 0. We have O rather. We have O. We have A. We have I. We have I. So how many do you have now? 4. So the probability of obtaining a vowel will be what? 4 over the total possible outcomes. 4 over 11. 4 over 11. Good. I can see people dropping answers here. Joshua says 4 over 11. Ogunbumi says 4 over 11. Good. Awesome. So don't forget our formula for probability. Probability of an event occurring is what? The number of possible outcomes over total number of possible outcomes. All right? The number of required outcomes, rather, over total numbers of what? Possible outcomes. Now, let's move on to questions that we have right here. Let's move on to questions that we have. So please drop in the comment section if you are following. Folake said 5 over 11. Is it 5? Please check it again. It's 4 over 11. We have 4 vowel letters there. O, A, I. Unless you are counting Y to be a vowel. No. All right. So we have O, A, I. In the word probability, we have 4 vowel letters there. All right. 4 vowels there. So please, there's no need to castigate anybody here, right? So even if you drop a wrong answer, all you need to get is just the correction. All right. Thank you. So now let's move on. This question says, what is the probability of obtaining a number less than 5 in a single toss of a fair die? What is the probability of obtaining what? A number less than 5 in a single toss of a fair die. Now, what is the total number of possible outcomes? If you throw a die up, what's the total number of possible outcomes? 6. Because in the die, you have 1, 2, 3, 4, 5, and 6. So if I throw a die up now, for instance, I can either get any of these numbers. I can either get 5, I can either get 6, 1, 2, 3, 4. So now let's solve. So what you need to do first of all is to what? Find your total number of possible outcomes. Please don't forget, when you are given a probability question, what is the total number of the possible outcomes I can have in this particular, probability question? So in this case now, we are talking of a fair die. They are not saying 2 die or 2 dies. A fair die. That means we are talking of 1 die here. All right. So the total number of possible outcomes from these will give you what? 6. So let's write the formula. P of E, that is P of the events. Don't forget, the events here is what? Obtaining a number less than 5. So what is the, let's list it out first. 1, 2, 3, 4, 5, and what? 6. So the total number of possible outcomes will give you what? 6. If you count it, 1, 2, 3, 4, 5, and 6. So the question now says, what is the probability of obtaining a number less than what? 5. Less than 5. A number what? Less than 5. It's very important, please. A number less than what? 5. So what are the numbers less than 5? In this, what we've written now. We have 1, 2, 3, 4, 5, and what? 6. So how many numbers are less than 5? 1, 2, 3, 4. Now, this question is very, very tricky because you might think 5 is inclusive, and it's even straightforward. It's not even tricky. Some questions will say, what's the probability of obtaining a number less or equal to 5? If you think they're just saying less than 5 and you count 1, 2, 3, 4, you get it wrong. But in this case, they're saying what's the probability of obtaining a number less than 5? So 5 is not inclusive. Please don't do what they did not ask you in the exam. 5 is not inclusive. So how many numbers are less than 5 here? 1, 2, 3, 4. And how many are they? Those are 4, right? We have 4. So number of what? The outcomes now. Number of the required outcomes is what? The number of required outcomes is number of required outcomes of the required outcome. Yes, here is the number of what they're asking you to find. Number of required outcomes is what? Is 4. That is 1, 2, 3, 4. So probability of obtaining a number less than 5 in a single toss of a fair die. Now, a single toss, always take note of what you are given in the exam. If you are not given something contrary, please don't assume. There's no need to assume in your jambo. Don't assume that, okay, they are talking about a fair die, they are talking about two die. What you are given is what you should use. So we have 4 over what? 6, and that gives us what? 2 over 3. All right, so the answer here is what? Is D. Please comment if you are getting this. I can go over it again and again. All right, so I can see that, oh, okay, you are getting it. Awesome, awesome, awesome. So that's the answer for the question number 1. So the answer is D. Now let's move on to the second question. All right, second question is like the same thing, and like I said earlier on, if you don't understand English, please, it will be very difficult for you to solve mathematics questions. So most of the questions in probability you'll be given in your jam will be word based, word problem based, word problem based. They won't just give you straight answer or straight question and be saying P of E equals to 2 over 3. What's it? No, most of it will be word problem based. All right, word problem is just in word, it's just in sentences. You be the one to interpret it and just solve the question. All right. So number 2 says a figure is selected randomly. For some of you that have been dropping answers, all right, I want you to drop this answer too because I want to test your knowledge on this, all right? And please don't check online. There's no need. That's why you're in a free class like this, all right? A figure is selected randomly from a group consisting of a square, a triangle, a rectangle, a trapezium, and a rhombus. How many, what's it called? Did they give us? How many figure? A figure is selected randomly from a group consisting of a square. That is, we have a square, we have a triangle, we have a rectangle, and we have what? Trapezium, and we have rhombus. That is 5. Square, triangle, rectangle, trapezium, and what? Rhombus. The question now says, find the probability that the figure selected is a parallelogram. Like I said, English is very important. First of all, you need to understand what a parallelogram is. If you don't know what a parallelogram is, there's no way you want to solve this question. You just be confused. You'll be like, there's no parallelogram in what we are given now. We are only given square, triangle, rectangle, trapezium, and rhombus. Where's the parallelogram? Why are they asking us to find probability that the figure selected is a parallelogram? Parallelogram is simple. The definition of parallelogram is shape with 4 sides, and the 2 sides are always equal. I'll go again. Parallelogram is what? Any shape with 4 sides and 2 opposing sides are equal. That's the meaning. So who can tell me now from what I told you right now that parallelogram is the definition of parallelogram I've given you now? Who can tell me the probability of obtaining a parallelogram? How many parallelogram figures do you have there? We have square, we have rectangle, and we have rhombus. Square, 2 sides of square are equal, right? Rectangle, 2 sides what are equal. All right, 2 sides are equal. All right, and rhombus also, it has 4 sides and 2 sides are equal. Those are parallelograms. So now I told you earlier on that what the first thing you need to consider or that you need to find is the total number of possible outcomes. So what is the total number of possible outcomes here? Total number of possible outcomes. Who can tell me? How many shapes do we have there? 5. That's our total number of possible outcomes. All right. Total number of possible outcomes is 5. Okay. So total number of possible outcomes. Number of possible outcomes equals what? 5. So now what are the parallelogram figure that I told you? Is square, rectangle, square, rectangle, and what? Rhombus. Square, rectangle, and rhombus. That makes it how many shapes now? 3. So what's the probability of obtaining that a figure selected is what? Is parallelogram. That will give us what? Probability that a figure is, let's represent it by E. Probability of E occurring. That is probability of that event occurring is what? The of number of what? Parallelogram that are there over the total number of possible outcomes. Please, if you don't understand this, let me know. That's why I'm breaking it down to the point where you can understand. That's why I'm breaking it down to a point where you can understand. Someone dropped an answer. Please check again. Check again, check again, check again. Parallelogram will give you 4 sides. So how's it and 2 opposing sides are equal? Please, that's the definition of a parallelogram. Please, if you check there, parallelogram you're having there is a square, a rectangle, and what? And a rhombus. All right. Trapezium is not a parallelogram. Neither is it triangle. Okay. So the answer is what now? 3/5, which is B. Which is B. Which is B. All right. Let's move on to the next question. The next question, we're going to be applying the principle, one of the principles here. All right. If the probability that a team will score 0 or will score 0 goals is 0.5 and 1 goal is what? 0.3. Find the probability that the team scoring of the team scoring either 0 or 1. Let me go over it again. If the probability that a team will score 0 goals is 0.5 and 1 goal is 0.3. So let's note it down. Let's write it somewhere. Let's write it somewhere. The probability of a team that a team will score 0 goal. Let's say the probability of 0 equals to what? They've given us already. That's 0.5. Abi? Probability that they will score 1 is what? 0.3. What is the probability? Let me write it very well. 0.3. The probability of what? That the team will score either 0 or 1 is simple. I already gave it to us already. That's what? Who can tell me what? Can someone drop it in the comment section? All right, Joshua, please, can you comment? I'm saying you don't understand. What is it that I don't understand, please? Let me know. You just drop it in the comments so that I can go over that again. All right. So the probability of obtaining what? Either 0 or 1. Probability of obtaining either 0 or 1. Right? That's P of what? A union B. That's what it means. Let's go back to our formula here. Let's check the formula. What does it give us? Probability of A union B. See there. Addition law. For mutually exclusive events. That means they can either score 0 and what? 1 or 1. They can't score 0 and still score 1. If they score 1, that means they can't score a 0 again now. That means that's been clear. Can you now see what I'm saying about mutually exclusive events? So mutually exclusive events cannot occur together. And that is where you use the addition law of probability. So for mutually exclusive events, so for a team now, for those of you that support Manchester United, for instance, the question says, what is the probability that Manchester United will score either 0 or 1? So you know that by the time they score, they've cleared 0 already. So it can't be together in a single match. I'll repeat that again. If you watch match, right, you're a fan of Manchester United, Manchester City, whatever, and someone asks you, maybe a friend of yours asks you, and this applies to those that bet, even though I don't encourage you to do that, right? This is where they do probability a lot when they are betting, all right? Now, if Manchester United is going to play tomorrow, 4 p.m., and someone wants to bet and say, what's the probability of them scoring 0 or 1? That's a mutually exclusive event. Because by the time they score 1, they've already cleared 0. So they can't score 0 and still score 1 at the same time. That's what these things mean. All right. So for mutually exclusive events, you use addition law. And how do you recognize mutually exclusive events? It will be there in your question. It will be there in your question. All right. So I know someone would have solved this already. Let me check the comment section. All right, Joshua said the trapezium one. All right, so now let me go over the trapezium one again very quickly. The question says a figure is selected randomly from a group consisting of a square, a triangle, and a rectangle, a trapezium, and a rhombus. What's the total possible outcomes that we have? You just count the number of figures that are there. You have square, 1, triangle, 2, rectangle, 3, trapezium, 4, rhombus, 5. So that's the total number of possible outcomes. The question now says, find the probability that the figure is selected is a parallelogram. Now, you need to understand what the parallelogram is, first of all, for you to solve this question, for you to understand how to solve this question. And I said something that a parallelogram is just a figure that has 4 sides and 2 opposing sides are what? Equal. A parallelogram figure or shape has 4 sides, like rectangle, for instance. It has what? 4 sides. And 2 opposing sides of rectangle, they are equal. A square, that's another example. It has what? 4 sides. A triangle has how many sides? 3 sides. So you know that that one is not a parallelogram. I already gave you a definition of parallelogram to be what? Any shape that has 4 sides and 2 opposing sides are equal. I don't know whether you understand it now. Please drop your comments now. Joshua. So now, how do we arrive at that's 3/5? So count the number of figures that appears to be parallelogram there. We have square, we have what again? We have rectangle, and we have a rhombus. So how many of them now? Square, rectangle, and what? And rhombus. Those are the number of what? The events occurring. So that makes you what? Gives you 3/5. 3/5. Like I said, understand first of all what a parallelogram is. If you don't know what a parallelogram is, there is no way you want to solve this question or you want to answer it correctly. And that's why I just gave you the definition of parallelogram. It has 4 sides and 2 opposing of the sides are equal. So a square, a rectangle, a rhombus. Those are examples of parallelogram. So that's why we have 3/5. 3/5. Please drop it in the comments now if you understand what I just taught you right now. Please drop it in the comment section if you understand what I just taught you right now. Okay, that's for Joshua now, right? All right, please let me know in the comment section if you understand that. All right, so let's move on to the next question. So let's conclude this question 3. All right, so I'll be wrapping up very soon, so that I can rest a bit before the next class. All right, so if the probability that a team will score 0 goals is 0.5 and 1 goal is 0.3, find the probability of the team scoring either 0 or 1. So whenever you see either in probability, either will mean this one will happen or that one will happen. Either means or, right? Either 0 or 1. Or in probability is plus. And in probability is times. Let me write this somewhere. Please, someone should note this. It's very important for your jam. Whenever you see or in any probability question, it means what? Add the probabilities together. It means plus. And means what? Multiplication. Please never forget this. Never forget this. So if that's the case, the question now says find the probability of the team scoring either 0 or 1. And this is a mutually exclusive event. So if one should happen, the other one cannot happen. So this is the last question we'll be solving right there. So the probability of A of scoring 0 or 1 will give us what? 0 union 1. And that gives us what? 0.5 plus 0.3. Don't forget our formula up there. If you don't understand, let me scroll down to where we have the formula again so that I can see it. This is where we have that formula, all right? Addition law. Can you see for mutually exclusive event, the probability of either occurring is P of A plus P of B. And that is what we are applying here, all right? So if you add this together, what do you get? 0.8. And that's where we'll be stopping for today. Please, if you understand what I just did right now, please comment in the comment box. Let me see whether you understand. All right, someone dropped the answer already. Good. 0.8. Very good. Very good. Now, for those that did not know before, now you understand how we arrived at 0.8. All right, please, I want to encourage you. This is just, a tip of an iceberg. By the time you register, which I will encourage you to do if you've not done that already, The main class is starting, all right, by Monday. We are starting on Monday, unfailingly. All right. So if you have registered, please encourage others to register. If you have friends that have not registered, and if you have not registered already, this is an opportunity for you to what? To register. So please follow our tutors on YouTube, on social media. Follow Lucy Knows English on YouTube. Follow, Dr. Jan. Follow, follow myself also. Follow, tutorial platform so that you can see as we are dropping content. It's very, very important. You need this, please. You need them. You need them. Please, I will encourage you again. If you have not registered, register. Just go on our website, tutorial.com//UTME. It will direct you on how to register. All right. God bless you, everyone. See you next time. All right. Bye.